Welcome to Sound Wiki. The Moon is an astronomical body that orbits planet Earth and is Earth's only permanent natural satellite. It is the fifth largest natural satellite in the Solar System, and the largest among planetary satellites relative to the size of the planet that it orbits, its primary. The Moon is, after Jupiter's satellite Io, the second-densest satellite in the Solar System among those whose densities are known. The Moon is thought to have formed about 4.51 billion years ago, not long after Earth. The most widely accepted explanation is that the Moon formed from the debris left over after a giant impact between Earth and a Mars-sized body called Theia. The Moon is in synchronous rotation with Earth, and thus always shows the same side to Earth, the near side. The near side is marked by dark volcanic maria that fill the spaces between the bright ancient crustal highlands and the prominent impact craters. After the Sun, the Moon is the second brightest regularly visible celestial object in Earth's sky. Its surface is actually dark, although compared to the night sky it appears very bright, with a reflectance just slightly higher than that of worn asphalt. Its gravitational influence produces the ocean tides, body tides, and the slight lengthening of the day. The Moon's average orbital distance is 384,402 kilometers, 238,856 miles, or 1.28 light seconds. This is about 30 times the diameter of Earth. The Moon's apparent size in the sky is almost the same as that of the Sun, because it is 400x farther and larger. Therefore, the Moon covers the Sun nearly precisely during a total solar eclipse. This matching of apparent visual size will not continue in the far future, because the Moon's distance from Earth is slowly increasing. The Moon was first reached in 1959 by an unmanned spacecraft of the Soviet Union's Luna program. The United States NASA Apollo program achieved the only manned lunar missions to date, beginning with the first manned orbital mission by Apollo 8 in 1968, and 6 manned landings between 1969 and 1972, with the first being Apollo 11. These missions returned lunar rocks which have been used to develop a geological understanding of the Moon's origin, internal structure, and the Moon's later history. Since the Apollo 17 mission in 1972, the Moon has been visited only by unmanned spacecraft. Both the Moon's natural prominence in the earthly sky and its regular cycle of phases as seen from Earth have provided cultural references and influences for human societies and cultures since time immemorial. Such cultural influences can be found in language, lunar-based calendar systems, art, and mythology. Formation. The Moon formed 4.51 billion years ago, some 60 million years after the origin of the Solar System. Several forming mechanisms have been proposed, including the fission of the Moon from Earth's crust through centrifugal force, which would require too great an initial spin of Earth, the gravitational capture of a preformed Moon, which would require an unfeasibly extended atmosphere of Earth to dissipate the energy of the passing Moon, and the co-formation of Earth and the Moon together in the primordial accretion disk, which does not explain the depletion of metals in the Moon. These hypotheses also cannot account for the high angular momentum of the Earth-Moon system. The evolution of the Moon and a tour of the Moon. The prevailing hypothesis is that the Earth-Moon system formed after an impact of a Mars-sized body, named Theia, with the proto-Earth giant impact. The impact blasted material into Earth's orbit and then the material accreted and formed the Moon. The Moon's far side has a crust that is 30 miles, 48 kilometers, thicker than that of the near side. This is thought to be because the Moon fused from two different bodies. This hypothesis, although not perfect, perhaps best explains the evidence. 18 months prior to an October 1984 conference on lunar origins, Bill Hartmann, Roger Phillips, and Jeff Taylor challenged fellow lunar scientists, "You have 18 months. Go back to your Apollo data, go back to your computer, do whatever you have to, but make up your mind. Don't come to our conference unless you have something to say about the Moon's birth." At the 1984 conference at Kona, Hawaii, The giant impact hypothesis emerged as the most popular. Before the conference, there were partisans of the three traditional theories, plus a few people who were starting to take the giant impact seriously, and there was a huge apathetic middle who didn't think the debate would ever be resolved. Afterwards, there were essentially only two groups, the giant impact camp and the agnostics. Giant impacts are thought to have been common in the early solar system. Computers' simulations of giant impacts have produced results that are consistent with the mass of the lunar core and the angular momentum of the Earth-Moon system. These simulations also show that most of the Moon derived from the impactor, rather than the proto-Earth. However, more recent simulations suggest a larger fraction of the Moon derived from the proto-Earth. Other bodies of the inner solar system such as Mars and Vesta have, according to meteorites from them, very different oxygen and tungsten isotropic compositions compared to Earth. However, Earth and the Moon have nearly identical isotropic compositions. The isotropic equalization of the Earth-Moon system might be explained by the post-impact mixing of the vaporized material that formed the two, although this is debated. The impact released a lot of energy and then the released material re-accreted into the Earth-Moon system. This would have melted the outer shell of Earth, and thus formed a magma ocean. Similarly, the newly formed Moon would also have been affected and had its own lunar magma ocean. Its depth is estimated from about 500 kilometers, 300 miles, to 1,737 kilometers, 1,079 miles. While the giant impact hypothesis might explain many lines of evidence, some questions are still unresolved, most of which involve the Moon's composition. Gravitational field. The gravitational field of the Moon has been measured through tracking the Doppler shift of radio signals emitted by orbiting spacecraft. The main lunar gravity features are mascons, large positive gravitational anomalies associated with some of the giant impact basins, partly caused by the dense mare basaltic lava flows that fill those basins. The anomalies greatly influence the orbit of spacecraft about the Moon. There are some puzzles. Lava flows by themselves cannot explain all of the gravitational signature, and some mascons exist that are not linked to mare volcanism. Magnetic field. The Moon has an external magnetic field of about 1 to 100 nanoteslus, less than 1/100th that of Earth. The Moon does not currently have a global dipolar magnetic field and only has crustal magnetization, probably acquired early in its history when a dynamo was still operating. Alternatively, some of the remnant magnetization may be from transient magnetic fields generated during large impacts through the expansion of an impact-generated plasma cloud in an ambient magnetic field. This is supported by the apparent location of the largest crustal magnetizations near the antipodes of the giant impact basins. Atmosphere. The Moon has an atmosphere so tenuous as to be nearly vacuum, with a total mass of less than 10 metric tons, 9.8 long tons, 11 short tons. The surface pressure of this small mass is around 3 times 10 to 15 atmospheres, 0.3 nPa. It varies with the lunar day. Its sources include outgassing and sputtering, a product of the bombardment of lunar soil by solar wind ions. Elements that have been detected include sodium and potassium, produced by sputtering, also found in the atmospheres of Mercury and Io, helium-4 and neon from the solar wind, and argon-40, radon-222, and polonium-210. Outcast after their creation by radioactive decay within the crust and mantle. The absence of such neutral species, atoms or molecules, as oxygen, nitrogen, carbon, hydrogen and magnesium, which are present in the regolith, is not understood. Water vapor has been detected by Chandrayaan-1 and found to vary with latitude, with a maximum at 60 to 70 degrees. It is possibly generated from the sublimation of water ice in the regolith. These gases either return into the regolith because of the Moon's gravity or are lost to space, either through solar radiation pressure or, if they are ionized, by being swept away by the solar wind's magnetic field. Orbit. The Moon makes a complete orbit around Earth with respect to the fixed stars about once every 27.3 days, its sidereal period. However, because Earth is moving in its orbit around the Sun at the same time, it takes slightly longer for the Moon to show the same phase to Earth, which is about 29.5 days, its synodic period. Unlike most satellites of other planets, the Moon orbits closer to the ecliptic plane than to the planet's equatorial plane. The Moon's orbit is subtly perturbed by the Sun and Earth in many small, complex and interacting ways. For example, the plane of the Moon's orbit gradually rotates once every 18.61 years, which affects other aspects of lunar motion. These follow-on effects are mathematically described by Cassini's laws. If you liked the video, please share and subscribe. And if you want more information on this topic, please comment or visit wikipedia.org.